All right, welcome back everyone. This is going to be our part 2 video for graphing polynomials. Hopefully the last one made good sense to you and you were able to do the Desmos activity. That'll be a big help for today. So just a quick review because we do need to remember that stuff from Monday for today's lesson. We talked about finding the degree and the leading coefficient of a polynomial so that we can determine the end behavior. Okay, so just a quick reminder, this one here is in factored form, because it is factored, right? We have this a factor times this factor times this factor. Those are factors multiplied together. And we don't need to FOIL it out because remember, all we need is the first term of a polynomial in standard form to be able to determine the end behavior. So we just talked about how really all you need to do is multiply the x terms together. So if I did that, I would get 2x cubed. So most importantly, that leading coefficient is positive, and this degree is odd. So a positive odd function would start at the bottom of the graph and end at the top. Okay, that's a review from last lesson. The next example is even easier because it's already in standard form. It's not factored. So we already can see that first term right away. That's a positive 1x to the even fourth power. So a positive even would start up and end up. Okay, this will be really important for today's lesson. So that was just a quick review. So hopefully you were able to do the Desmos activity like I said. It kind of introduced you into zeros, or remember a zero is an x-intercept of a graph. And we get those x-intercepts from the factors. So what you hopefully realized is if you set those factors equal to 0, and we've done this before, but if you set x plus 3 equal to 0 and solve for x, that means x equals negative 3. That is an x-intercept at negative 3 on the graph. And then same thing here, if I set x plus 2 equal to 0 and solve, and I know a lot of you can just do this in your head, if we solve for x, we'd get negative 2. That means that there's an x-intercept of negative 2. I know those are really close together there. And then the last one, our x minus 1, if we set x minus 1 equal to 0 and add that 1 over, that means x is 1. So x-intercept of 1 there. Okay, and even more so, we could do a quick review of what we just talked about. If I wanted to find the leading coefficient and degree, this is factored form, so I'd multiply all those x's together and I'd get a positive x cubed. So I know that this graph starts at the bottom and ends at the top. So the only thing left we have to figure out is kind of what happens in the middle. How does it curve? Does it bounce? Does it curve? What does it do? So we'll learn that on the next slide, but we're getting really close to being able to graph a complete polynomial. All right, example 5 here is very similar. The thing I wanted to show here, though, is this x in front that we forget a lot of times. Think of an x as x plus 0. So I could still set that equal to 0. If I set x plus 0 equal to 0 and solve, we just get x equals 0, right? But that is an x-intercept. That means it crosses the x-axis at 0. So don't forget, anytime there's an x out front, a GCF, that means it's going to cross the x-axis at 0. This would give us negative 3 based on what I just talked about. This would give us negative 1. And this would give us positive 2. So this graph had 4 x-intercept. And notice there were 4 different factors. We had this times this times this times this. So 4 different factors. That's important to note. They're all different, gave us 4 different x-intercepts. And if I wanted to quickly review our degree and leading coefficient, if I multiplied all of these x's together, this would be a negative x to the 4th polynomial. So negative even, so our degree is an even 4. Negative even means it starts at the bottom and ends at the bottom. Okay, and then we're going to figure out in just a minute kind of what happens in between. And really the last thing that you learned, hopefully from Desmos, and really the last part of this activity is a concept called multiplicity. Okay, and multiplicity, I'm going to cross this out real quick because I have it on the next page before I forget. Multiplicity is basically how many multiple number of times does a common factor occur. So for example, this factor only happens once. I only have one x minus 4. But notice the factor before it, x plus 3 squared, really that's x plus 3 times x plus 3. So I would say that factor has a multiplicity of 2 because it occurs twice in this equation. So if a factor has a multiplicity of an even number, most commonly it's a 2, that means the graph will bounce off of that x-intercept. Okay, and if it's odd, for example, like this one here, there's only one of those. If it's odd, it's going to cross through that x-intercept. Okay, so let's put this all together here. So the zeros I have, I know that it's going to, from this factor here, it's going to cross at 2. And I'd say that factor has a multiplicity of 1. So you can just write m:1 for multiplicity 1, and I'll know what you mean. Okay, so I'm going to go ahead and plot that x-intercept at 2. This factor, if I set x plus 3 equal to 0, I would get x equals negative 3, but that has a multiplicity of 2 because that factor is squared. So what I like to do is I'll plot that x-intercept, but then I will put a little lowercase b next to it to remind myself that when I get to that x-intercept, the graph is going to bounce. And then the last one here, if I set x minus 4 equal to 0, I'd get positive 4. And that, once again, has a multiplicity of 1. And there's an example like this on your pretest, and this will definitely be on exam 4. So dual credit students especially, make sure you kind of understand how I wrote these, and you can write it the exact same way. Okay, so if I plot that last x-intercept of 4, that would be right here. Oops, that was kind of sloppy. Let me erase that. Okay, and then the last thing we need to do to kind of put this all together is to determine that leading coefficient and degree. So if I multiplied all these x's together, and remember this is x squared because there's 2 of those. So x times x squared times x would be a positive x to the 4th, which means this graph is going to start at the top and end at the top. And this is just a pretty vague sketch. We're not being real exact here. You should just be able to get the basic idea of the graph. But if I connect these together, I'm going to kind of go on my little roller coaster ride, I like to say. I'm going to bounce off of this x-intercept. I know I'm going to cross this one, and I end up like I knew I would. And that's a really good way, or a good representation of this graph. It's not perfect, and if you graphed it in Desmos, it might look a little bit differently. So for example, I don't necessarily know how high this hump should go or how low this hump should go, but we're just getting an idea, and I'll show you here on the last example. You can always find the y-intercept, and that'll give you another idea to make this graph a little bit more accurate, but that's pretty much the basic idea right here for a factored polynomial. So I'm going to do one more of those, and like if I'm going too fast, pause it, slow down, rewind, whatever you need to do. But I'm going to do one more example in factored form, and then I'm going to do one example that is not factored. Excuse me. I don't have the Rona, sorry about that. But I'm going to do 2 more examples here, and we'll be done. All right, so let's start off with this one here. The degree, x squared times x would be 4. So this is a degree of 4. The leading coefficient would just be a -1 because of that negative in front. If I multiplied all the x's together, I'd get a -1. So the end behavior, this is an even degree with a negative leading coefficient. So over here on my graph, I'm just going to mark that I know it's going to start down and end down. Okay. Now the x-intercepts, remember the way that we find our x-intercepts is we just set each factor equal to 0. So if I set this factor equal to 0, I'd get x equals 5. If I set this factor equal to 0, I get x equals -4. And x squared is basically x plus 0 squared, right? But I could still set that equal to 0. Remember, I get 0. Okay, so I do have 3 different x-intercepts. So 5, -4, and 0. And this one here has a multiplicity of 2, right? Because that x was squared. So I know that this graph is going to bounce at x equals 0. This one had a multiplicity of 1, and this one also had a multiplicity of 1 because those factors only occurred once in the equation. Okay, so if I go on my little roller coaster ride here, just kind of a quick little sketch. It's going to start at the bottom. We know we're going to cross, but then we're going to bounce, and then we're going to cross, and we should end down. So that is a good guesstimate of what this graph looks like. Okay, and you could graph it in Desmos, you could graph it on your calculator, and you'll see it looks very similar. These go up a little bit higher, but we will talk more about that in just a second. All right, our last example. I'm trying to keep these videos pretty short. Looks like we're at about 11 minutes. So this is a polynomial that is not factored. Okay, so this is where you're going to have to be able to factor to get to that point like the one that we just did. Once it's in that form, we'll be good to go. Okay, this is not factored. So the easy thing to find is the leading coefficient. I'll go ahead and write that down. The leading coefficient is 2, and the degree is 3. Positive 2, odd 3. Positive odd, we know is going to start at the bottom and end at the top. Okay, so first step, when it's not factored, let's just get that out of the way since we can see the leading coefficient really easily. Okay, next step, we need to factor. Okay, so this has 4 terms. So the way that we factor this is by grouping, remember? So we split it in half, and then we pull the GCF out of the first half. So both of these terms have x squared in common. And if I factor out an x squared, I'd be left with 2x plus 3. And now if I look at the second half here, those don't have an x in common, but -8 and -12, and they're both negative. Both of those divide by -4. So if you factor out that negative, that will make the inside positive, and -8 divided by -4 is 2, and -12 divided by -4 is 3. And remember, in factoring by grouping, our goal is to always get these to be the same. So the next step is we factor that out because both of these terms have a 2x plus 3 in common. And when that's gone, I'm left with x squared minus 4. If you need a refresher on factor by grouping, if you just search factor by grouping in Khan Academy or YouTube, there's a million examples. So take a watch on one of those if you need. And then we always have to factor as far as we possibly can. And you might notice here that's an x squared minus 4. That's a difference of perfect squares, which we can factor as x plus 2, x minus 2. Okay, so all of that factoring we've done this year is really important for this part of the exam. So notice we have 3 factors now. The next thing we can do is we can find the x-intercepts. So if I set this factor equal to 0, I'd get 2. Go ahead and plot that. And that factor has a multiplicity of 1, so we know it's going to cross. It's not going to bounce. This factor would give me x equals -2, also with a multiplicity of 1. And if I set 2x plus 3 equal to 0, I would get -3 halves, or -1.5, which is really close to that. I'll try and separate those. Also with a multiplicity of 1. So none of these are going to bounce. It's going to cross, cross, cross. Okay. One more quick detail that I told you I was going to show you. We can always find the y-intercept, which is just one more point that makes our graph a little bit more accurate. And the way that we find the y-intercept is we just plug 0 into the equation for x. So if I go back up here and if I plug in 0 for all of my x's, well, that term cancels, that term cancels, that term cancels. I'm left with the constant. So my y-intercept would be -12, which would be a little bit below the graph. It would be about right here. but that kind of shows you how far that hump is going to go down. So we at least know one of them a little bit more accurately. Okay, so last part's the easy part. We got all the information. Now we just need to go on our little roller coaster ride and connect the dots. So we know we're going to start at the bottom. We're going to come up here. We're going to cross, but don't forget to go down and hit that y-intercept. And then we're going to cross, and we know that the graph will end up. Okay, so this is just one example. They're all very similar, this exact same process. Obviously, factoring is different based on the different polynomials, but that's why we have factored so much this semester, is so that we can graph these polynomials. Okay, so this is the last example for today. If you have any questions, feel free to email me, take a screenshot of a problem you're working on or you're confused about. You can email that to me, or you can show up to my video conference office hours any day, any weekday at 1 o'clock. That calendar is posted in Google Classroom. So anytime you can log in at 1 o'clock and I'll be there on the video chat. It's really easy for me to explain things and help you out there. Okay, so let me know if you have any questions. That is all for today, and that is all for the rest of this week. Thanks for watching.